Okay, cool. So, hey everyone, my name is Karthik. I'm a ST1 front end here at Ticker. So today we'll be looking into intro to WebAssembly with AssemblyScript. So we'll be slightly touching upon what WebAssembly is and why people are using it, and then we'll look further on how a typical web developer who always works with JavaScript or TypeScript can get started with writing their functionality at a WebAssembly level. Okay, so that's what we'll be most looking into in this um, presentation. So moving forward, we'll see what is WebAssembly, right? So we'll see a standard definition like WebAssembly is an open standard whose objective is to offer near native performance on the web while maintaining compatibility with the current ecosystems and standards. Okay, as in near native performance, as in when you compare your JavaScript execution at a a heavy throughput kind of environment, it is kind of slow with respect to other programming languages that run. I mean, that doesn't do any runtime level checks or anything as such, right? So what happens here is like if you're using WebAssembly on web, you are you will be able to get near native performance. You cannot assure that you'll be getting the exact same thing that you'll be getting if you're running the app natively, but it's a kind of close to near native performance. And at the same time, web has been there since many years, and this has to be introduced in such a way that it doesn't break anything that already exists, because we already know that web as an ecosystem is a lot fragmented, starting even a simple thing as making a network request with fetch might not support in any older browsers, right? So this has to be introduced in such a way that it doesn't break any current ecosystem and standards, and it has to play very well with what's already existing, right? Uh, let's see another one, a little bit deeper and technical. Here, WebAssembly is a binary instruction format designed as a portable, portable as in size and load time efficient compilation target for programming languages. So there are like so many words that written in this particular sentence. So let's see. Things is first one is the binary instruction. So what do you mean by binary instruction? So what's happening here is if you're writing your code in JavaScript, at the end of the day, the browser receives the JavaScript code and it has to go through many things before it gets executed on your browser, right? And so what will happen here is like your browser will download it, interpret it, and convert that into a machine code and apply some optimizations by the underlying engine, maybe V8 in Chrome or any Chromium based browsers or anything as such. Okay. Here what's happening is the binary instruction format is like a very low level format that your machine can understand straight away without any these intermediate steps that will happen usually when you write or and ship your JavaScript code. Okay, and the second one is portable being size. Obviously size is the pretty straightforward thing, and load time efficient as in um, assume you are shipping something instead of shipping your entire logic as a single large file. You may want to split that into a smaller chunks of things, so that assume there is very user heavy operation that happens on any particular screen of your page. You should be having the capability of loading only that particular logic. I mean, your native logic or any complicated logic at that particular instance of time, and make it run. So that is load time efficient. And the last one is compilation target for programming languages. So here the word compilation target for programming languages as in, so the word compilation we can close it related to in such a way that it takes a programming language from can say format A, and it can convert that into a format B, so that it can we can directly execute the format B that we are getting. Okay, we'll see what this compilation target for programming languages actually mean in the next slide. So if we go to the next slide, that's what we'll be seeing much deeper. So here we have like so many languages like C, C++, C Sharp, Rust, Go, Kotlin, Swift, and many more languages. So what's happening here? These are all the languages which many other non-web developers might already know. Okay, who are into backend or who are into developing any uh, Windows native applications using .NET or anything as such. So those people might know these kind of languages, or even Kotlin. Kotlin is majorly used for Android apps these days, and Swift is like your first hand programming language for iOS applications. So what's going to happen here is you'll take all these such languages and then you'll be creating Wasm binaries. So Wasm here is the same thing. Wasm stands for WebAssembly. So what's happening here is this is allowing any non-web developer to be able to ship the same logical or functional code that they have written in any of the programming languages if there is supported compilation tools available for that particular language. They can easily port their code into Wasm such a way that it can easily start running on web platforms, right? And along with that, as I mentioned, as Wasm is a binary instruction format, so there's no way that I mean, usually in the web world we are like very much accustomed to debugging directly in the browser itself, where you will open the source control tab on your developer tools and you'll start debugging the code, like where the code is flowing and all. As Wasm is a binary instruction format, you cannot basically simply go and see what's happening over there. So these compilation targets, compilation programming languages also allow you to generate another file called what. What is your WebAssembly in text format? So you can use this to see the flow of the code and where you want to add your own debugging point or anything as such. So this is one more thing. We won't be going any much deeper into how WASM looks like or how what looks like, but this is like an overall understanding of what is programming languages by using your particular compilation tools and then convert those things to run on web using WASM and another debuggable format called what. So here's some main differences between WASM and what. WASM is a binary, what is a plain text format. WASM is machine readable and what is human readable. And WASM is the main thing that we'll usually use for execution, and what is your file for editing or debugging on the go, right? Okay. At the same time, as it's a we can say as a programming language or a language in general, every language does come with their own set of data types or internal inbuilt functions or anything as such. So we'll touch up two main things coming to WebAssembly. We'll touch upon data types, and then we'll also touch upon another thing called operation codes. Okay. So starting with data types, so I mean, if you are a web developer, you will be knowing, right? It is number, string, arrays, objects, sets, maps, and all such things. But when coming to these kind of low-level machine languages, especially for WebAssembly, we have only a particular set of data types that we do support. So if you see now, what we have is number. Okay, all these are number types, and if you see, we are going much deeper and much specific. In this case, we are saying something like if it's a 32-bit integer or a 64-bit integer. At the same time, we are saying if it's a floating point value, if it is a 32-bit floating point value or a 64-bit floating point value. Okay, and at the same time, there are multiple things like vector type. Vector type is something where it's a 128-bit representation of data, right? And other things are like references. References may be pointing out to your if you're familiar with any other strictly typed languages, you might be knowing about the word called pointers or something as such, right? So these are references types. and you have function type. These are your usual functions, which usually you might take an input and you might expect to give an output and something as such. But if you notice here, you are not seeing any of your usual data types. Usual data types, as in there is no string, there is no arrays or object sets, maps, or anything as such, right? So whenever we are targeting for these kind of uh, low-level languages, or especially WebAssembly in our own context, we don't have any of those things straight away. Like you cannot simply do like a variable that you can declare as a string and you can not directly play around with it. We'll see how and where we can do such things. But as of now, as an overall understanding, this is what it is. You'll be getting numbers, you'll be getting references, you'll be getting functions and something as such. Okay, cool. And moving forward, as I mentioned, there is something called opcodes. Opcodes is again abbreviated as operation codes. So what will happen here is like usually if you can take an example of JavaScript, assume there is a function and function might be accepting two arguments, maybe A and B. Um, what you'll usually do is like you might simply say return A plus B, something as such, where A is an operand, B is an operand, and the plus that you write in between is an operator, right? But here in this case, things are not that straightforward. So if you see, we have like so many opcodes that is available within WebAssembly. Basically, if you can take an example, let's see this local.get. So local.get is a something where you will be able to accessing a variable that is available in your local scope, right? Whereas if you are working with JavaScript, all you need to do is like simply use a variable or any parameter straight away, like A, B, or whatever it is. And similarly, say you want to do an operation where you want to check if two numbers are equal or not, you'll be simply doing a equal to b, assuming both the numbers are equal. You'll be getting true or false, but in this case it's not that straightforward. We have to do something like i64 dot eq, and we have to deal with these things. So there are many such type of opcodes that end of the day that gets executed on your machine. I mean essentially in our context we are only talking about um, what do we say, browser. Okay, so this is as far as you guys seen till now. If you see, there are many more complications in writing WebAssembly code straight away, being data type restriction, as in you're having only numbers, even though you have much more control on what type of number that you are defining. There isn't much you can do, and then you're having access to what do you say, memory, as in if you're declaring anything, you have access to those things as a buffer in memory, but still it's not easy to play around with actual buffer data than directly manipulating your string or an array or something as such. So this is one of the main reasons why WebAssembly is not meant to be handwritten on your own. So the highest and most important thing that you should remember here is that it's a compilation target for other programming languages, so that you can write in your other programming languages. In our case, it could be C, C++, or anything that has a compilation tool available to convert that into a WebAssembly target. Or if your company or if your product demands in such a way that you want to work with very high throughput real-time data or something as such, where you cannot afford any what do you say, delays in computation or anything as such. So in those cases you might want to write your own code in any other language and port it back to WebAssembly and run it on your browser. But majorly people use it to port their existing application that's already been written in any other languages, and they just want to try to bring that to web ecosystem. So we'll see a few more examples moving forward. Like there are many companies that are actively using WebAssembly in their products. Uh, we'll see that in the further slides. And after seeing this, I mean, till date, it was like a monopoly in the browser ecosystem that JavaScript is the only thing that can do anything functional in the browsers. But as the WebAssembly kind of new kid is entering into the market, like people might be start thinking like, if will WebAssembly replace JavaScript in any sorts? There's a straightforward answer to that. The answer is no. The reason being, WebAssembly in essential is designed to be a complement to JavaScript, as in, uh, so in browser, the highest and the most popular thing will stay as JavaScript itself, because while WebAssembly will over time allow many other languages to be compiled and be able to run on the web, JavaScript will remain the same and has the major player because it has been there since many years. Even if you take example of PHP or anything, many legacy applications or even WordPress, which many of the websites that still depend upon is still running on PHP. So JavaScript in essential is not going anywhere. So no need to worry about anything as such. And also WebAssembly is built in such a way that the main concept behind WebAssembly is it's a module. I mean, if you're from the web ecosystem, you can synonymize it with ES modules, where essentially that cannot execute by itself. You will have to import it, and you will have to access it or execute it or anything as such. In the same way, WebAssembly works the same. If you have a WebAssembly module, what you'll have to do is you'll have to import it, and then you can execute in whatever you want to do. So the example that you're seeing here is this is your usual fetch that we use for our network requests and all. We are simply pointing that to a Wasm file on the network, and then what we are doing is we are using WebAssembly dot instantiate streaming, okay, and then we are simply passing the fetch. And what's happening is here is it's an await statement. So what will happen until the browser downloads the Wasm file and processes it, the line execution will be waiting. And then once you get it, as it's an object, sorry, as it's a module, you'll be expecting a few exports from the module. So it is instance dot exports, and it's exposing many things. You can accept, you can access any function, and you can pass arguments or anything as such. So this is the main ideology. Like WebAssembly within itself cannot run straight away. It needs even a teeny bit of at least these 3-4 lines of JavaScript glue code to get things started. So JavaScript is not going anywhere anytime soon. Moving forward, is anyone using WebAssembly? Let's see. There's one major thing called Blazor. So Blazor advertises itself as a way to build client apps with C#, as we have seen in second slide or somewhere, where there's a list of programming languages which will allow you to port that particular code and be able to run that in the browser. So Blazor is one such full-fledged framework where you can write your code in C# and it will allow you to bundle up the code in WebAssembly, and you can execute it on the browser. One more advantage here is like, as it's built on C#, you can also bring in your existing C# code. Maybe you have a library that does some number manipulation, or you want to bring some image manipulation or anything as such that your company is already having in C# or in such languages. You can bring that in. You can easily start porting that code over to web and make your web app available pretty quickly. So that is one thing. People coming from C# and such ecosystem, and anybody who's looking for anything quite cross-platform, that's where Flutter Web comes in. So Flutter within in itself is a cross-platform app development can say framework or anything as such. So what happens here is like you'll be writing a single Flutter application that will be written in Dart. Okay, and during the compilation time, when you're exporting the app to Flutter Web, we do have an option to if you see, there are two different options available. One is HTML renderer, and another one is the Canvas kit renderer. So what will happen is whenever you're exporting your Flutter Web app, it usually sees in the browser, if it's running on the desktop, it'll automatically be choosing yeah, I'm actually pointing out to this particular point. So it'll choose the HTML renderer if it's on a mobile browser, and it'll choose the Canvas kit renderer on a desktop browser. So what is happening here in Canvas kit renderer is like all you will see is like a little bit of HTML here and there in order to get the, what do you say, inject the scripts, or in order to provide any meta tags or anything as such. But the main content that you'll be seeing for the entire application will be within uh, a canvas, right? So this is one more way how uh, I mean, frameworks are taking advantage of WebAssembly to bring cross-platform applications to web. Okay, cool. There are a few more things and companies who are using WebAssembly in action. So I've attached link to everything. We'll open a few, and the rest all you can see from the, what do you say, the slides. So I'm opening Google Earth. So if you see Google Earth, I open the network tab and I switch the filter to Wasm. And if you see, Google Earth is accessing earth.wasm file. So whatever you are seeing here, I'll show you by inspecting it. So everything is here is within a canvas, right? The moment I take it out, you won't be seeing anything except for other functional UI. So whatever you're seeing on the Google Earth, that is basically I think it was in C++ code base, and they ported that over to web using WebAssembly. And similarly, we can see Figma. Figma is also another prototyping and designing tool, which heavily uses Canvas Kit as their rendering engine on the web. And these are like two examples where they ported existing code base into web. The third example is like Squoosh. Squoosh is your image manipulation, cropping, rotating kind of tool that's available on the web. So uh, what's happening here is the moment I try to open any image to manipulate it, if you notice, they are bringing in functions that is allowing you to rotate and convert between maybe an SVG to Mozilla's JPEG. So what's happening here is these encoders and tools are already been written in native languages many years ago. So it doesn't make sense to write these logic on your own in JavaScript and implement in your web app, whereas you can directly port those what do you say, libraries or sort into WebAssembly, and you can get started with using those things on your web platform. That's a second kind of example. And third kind of example is Stack Blitz. Stack Blitz is a compelling player in recent times. So what's happening here is as assembly, it runs natively. It comes with its own security benefits, as in it gives you, your own complete isolation of code execution. So what's happening here is StackBlitz is working on something called web containers. Containers, I mean, I think it's not open source yet, but they are trying to make it open source where you're able to run your entire a containerized environment in your browser, so that you can start executing stuff on the browser itself. So if you see here, I have, I'll go to this mode. So if you see here, we have a package JSON, which essentially means it's a JavaScript package, right? So we are actually running it within the browser. So this is one more compelling way of using WebAssembly. And moving forward, WebAssembly is not just restricted to the browsers. We can take it beyond browsers, where Cloudflare workers is actually using WebAssembly in such a way that they're allowing, I guess, C++ code to be able to run at the Cloudflare worker site, so that any native logic that is already existing, maybe say image compression, or maybe say compressing your static assets too broadly or something as such. If you want to control anything as such, you can write or port your web workers, not the web worker, I mean the Cloudflare worker logic with from C++, and you can directly deploy it on Cloudflare workers, and it will be able to execute it. And the next option is we have is Fastly's Compute at Edge, where Fastly is allowing you to write Rust code and make it able to deploy it on their vast edge network, so that you can intercept your requests or responses and act accordingly. So this is still within the web ecosystem, but beyond browsers. And then we have like Amazon Prime, Disney Plus, BBC iPlayer, and all, where they have to support um, what do you say, wide variety of devices across set-top boxes and smart TVs, mobile phones, and all. So they're writing the code natively, and they are porting it over to wide variety of set-top boxes, TVs, and all. And the last thing here is Flight Simulator. So it's a game. Usually, shared libraries are shared with maybe .so files or .dll files, but Microsoft Flight Simulator is slowly moving towards sharing their shared logic through WebAssembly. And one of the co-founders of Docker said that if Wasm plus WASI existed in 2008, they wouldn't have built Docker um, publicly, because WebAssembly is that much powerful with its system, its interfaces, and its containerized security and all. Moving forward, we'll see how a typical web developer who just knows JavaScript and TypeScript can get started with creating their own WebAssembly modules. Uh, so as usual, any problem on web coming to logic, JavaScript, gets to give us many of the runtime errors or even development time issues. So TypeScript has come in and helped every developer a lot. So again, in this case, TypeScript has come to us for the rescue, and the combination here is WebAssembly plus TypeScript. So there's something called AssemblyScript. So AssemblyScript is a TypeScript-like language for WebAssembly. It's not your typical, I mean, it doesn't convert your TypeScript code into WebAssembly, but it's like a TypeScript-like syntax which can or which has the ability to convert and produce a WebAssembly binary. So how does it look like? So it looks something like this. It's a usual JavaScript, okay? Only this particular part feels like TypeScript, but not entirely TypeScript, because if you notice in the beginning, I've told WebAssembly has its different ways of, different types of data types. It'll go much deeper on what exactly a number is, what exactly if it's a floating point number or it's a integer. So here we're simply saying we are passing an input that's a 32-bit integer, and we are expecting a 32-bit integer as an output. Okay, so as I mentioned earlier, the compilation target will generate two files. One is WASM, that's your binary file, and the other one is WAT. So if we see, this is what your WAT file will look like. So what is WAT? This is WAT. So you see, you have a function. Okay, it's accepting an argument, and it's expecting a return type of 32-bit integer, and these many things are happening within the function, where as I was mentioning opcodes, right? So this is one such opcode where he declared a constant variable, and this is another opcode where he's accessing the this particular parameter. Okay, and if you're running it, it runs straight away. Okay, as I mentioned earlier, there is a thing called WebAssembly.instantiate streaming, where you can simply pass fetch with a particular file, and it will start. You'll get the WebAssembly file as a module. You can import and execute it. Okay, cool. But we are still stuck with the problem of not having arrays, strings, or anything as such. So AssemblyScript provides the same. So they have a concept called loaders. So instead of simply doing WebAssembly.instantiate streaming or anything as such, if you can use AssemblyScript's loader, what's going to happen here is, if you see, it's the same syntax. We are simply passing a fetch. It's returning a promise. The only thing is we are using AssemblyScript's loader, and that in itself will give you the ability to create arrays and such. So what's happening here is, so this is your exported module, okay, and this is your function, okay. When you're using AssemblyScript loader to load this particular WebAssembly file, it exports another function that is underscore underscore new array. So what's happening here is, as I mentioned earlier, WebAssembly supports numbers and wide variety of reference types. So here we are passing a pointer. So what we are simply doing is we are creating an array. Okay, we are getting the address location from the same export, and then we are passing the actual JavaScript array. Okay, that is in turn is giving us a pointer. Okay, and we are passing that pointer to the function that we already have. So this is one way where um AssemblyScript is helping us in supporting strings and what do you say, arrays. But still, there is no support for objects or anything as such, or any other data types like sets and all. But as far as now, numbers, strings, and arrays are supported. So they have the same way for creating, reading the arrays, etc. So let's see one little demo and uh, get to know how it actually works. So if you see, we have a simple, the same Fibonacci series function. So it's a simple TypeScript file. Okay, there isn't much that's happening here. And then if you see the package JSON, we simply have AssemblyScript as a dev dependency and AssemblyScript loader as your dependency, so that you can load the AssemblyScript file. And if you see the index.js file, simple, we are importing the loader. We are doing loader.instantiate sync as it's running in, what do you say, Node.js environment. We're loading it synchronously. We can also do it asynchronously, but we are doing it synchronously here because we are reading the file synchronously. So instead of having a URL path, as it's Node.js environment, we are directly loading it from the file system. So we have a simple test. The test is for a Fibonacci series for the 10th number. It's 55. So we are simply asserting whenever I pass 10 to the function, is it returning 55 or not? And at the same time, I'm console logging the module so that I'll show you all the inbuilt functions that is coming along with AssemblyScript. So in order to run this, we'll simply do npm run as build. So this is coming from your package JSON. So this is the build command as build. So now we can simply run the test that I have, npm test. So if you see, the test has passed. There is no issue. So it didn't throw any error or anything as such. But the console log that we made, instead of the simple fib function that we made, we have all these functions like, if you see, we have a way to create a new string, we have a new array, get array, and everything as such, right? So this is coming as we are using AssemblyScript's loader. And one more advantage is, if you're using AssemblyScript to build your logic, and if you have a requirement that your code has to run in older browsers also, so what you can do is, as it's written in TypeScript, you can simply run a command. Here in this case is TSC, you're wanting it to the project that is within the AssemblyScript folder. So I'll simply run npm run build ts. So it will give you a JavaScript file. So you can, check if your browser is supporting WebAssembly, and if yes, you can do the logic of using AssemblyScript loader or even native WebAssembly loader to load the file and execute it. If not, you can simply execute the JavaScript file so that you can maintain the compatibility for older browsers also. And I think that is all for today. I hope this was a useful session.